the ugly part of any commercial building. The place, the graveyard, where nobody likes to go but the brave maintenance man. We are in the bit that makes all the commercial buildings in London function. The most critical and important bit that houses all the machinery and all the plant in one place, and it's iClimate's job to ensure that it all whistles along as it should be. This is my Hammersmith site. We've got an old BMS system that is due to be updated. We've got commercial boilers, Rahima 210s, that we service annually that need to be replaced at some point. We've got a ducted McQuay water chiller. For the aircon guys, you'll notice this is one of the first ducted indoor unit chillers here, right? So that means the chiller's in the plant room. There's no space for it outside. This is the original installation. We look after all the air movement across the building, and that is through all the large ductwork that you see here. We've got 1, 2, 3 large AHU plants with heater batteries that have hot water going to them. These are really old AHUs, originally manufactured by Flacked-Woods. This is about 25 years old. With the energy crisis and the increase in energy bills right now, key mechanical industrial plant is very expensive to run. So we're at a time right now where it's even more key to ensure that all your machinery and plant are integrated together and operating as harmoniously and energy efficiently in your building as possible. This ensures that it's comfortable inside, it's good for function, for your use, and it saves you a lot of money on annual running costs. So the key point to this is the brain of all the mechanical systems, and this is this large control panel here. It's a very old BMS panel, you can tell by the size of it, but on the BMS panel we've got all the mechanical pieces of equipment that it is wired to control, right? It's got green indication lamps, you've got lamps that indicate running, indicate errors with tripping, and you've also got a manual switch here, which allows you to put it into auto mode, which means the BMS will control when the plant comes on according to schedules. You've got an off in case you need to turn something off and isolate it from the BMS and locally, and it's got a hand. Hand means that you want it to run right now. It's a manual override, right? So as you can see, boiler one's on hand. You can see the CT pumps, what we're hearing right now is on hand. Nothing is on auto because the BMS needs to be updated, right? So we've got numerous lights out. Chilled water pumps are on auto. You can put them on hand. You'll see there's no illumination here. We've got all the secondary pumps here. We've got extract fans, supply fans. Again, more extract, humidifiers, and we've got AHU operation lamps to let you know if they're going on defrost or on frost in the winter. And we've got the main piece of kit here. That's the large air conditioning system, the McQuay chiller. That's on off. Put that on hand. These are not heads. These are inverter modules. So this is essentially the inverter PCB, but for a commercial ventilation application. Okay, so this is what drives the very large industrial fans, whether they be supplies or extracts, and it controls their speed essentially according to what's required. These are essentially a soft starting mechanism as well. Back in the day, before they had inverters, they used to have very large contactors called star and delta. So the electricians will know when the windings were wired in a star formation, that would be the best setup for low current draw upon startup. And then as soon as they're changed over and the motor gained some revolution and speed, it would then move into a delta setup for the windings for a residual low current operation. That's gone out the window now. We've got a soft start function on these where they basically can start up a very large industrial motor with about half an amp or an amp. So these are just the small things that we look after as part of our commercial building maintenance service for Hammersmith here. Right, behind me is this lovely 142 kilowatt McQuay Dakin chiller, okay? This chiller is sitting inside the plant room like I mentioned earlier because permission must not have been allowed when the plant or the fit out of this commercial building was carried out about 20 years ago to place a chiller outside. So in this situation or this scenario, the chiller gets placed inside and it's a ducted version. So there's lots of ductwork bringing fresh air into the chiller, across the condenser, and then from out the condenser to outside, okay? So plant rooms that have ducted chillers are essentially heavily ventilated plant rooms, right? You'll see a large cross-sectional area of weathered louvers that allow the plant room to breathe, essentially, right? To stop the chiller overheating. So you understand, being a water chiller engineer used to be a very dying niche specialist trade within the refrigeration industry, right? So chiller panel, you open it up. Everybody's remember these, the PCO2s, Corels. We've got 2 of the inverter packs, see? Inverter packs for compressors here. So we've seen inverters that relate to air handling motors, and we've got inverters here, VAR1 and VAR2, which relate to the 2 compressors and the 2 circuits that are in this chiller. This chiller is really old. We've come to site and we found that the liquid filled gauges, some of them are reading high pressure near zero on 2 circuits. This chiller is 142 kilowatts capacity at 35 degrees C condenser ambient, and it will provide a delta T of 7 to 12. That means that this chiller will pump 7 degrees C chilled water from here through the pumps to the local fan core units, which are basically the water AC units within the building. It will provide it to them, or in this scenario, it will provide it to the air handling units that are supplying all the air into the space, and it conditions it there. So the air handler is essentially a very, very, very large fan core unit for the entire building. So chillers have sometimes a numerous set of refrigeration circuits. The principle of the air conditioner still maintains here, but what's happening here is just at a slightly larger scale. Instead of us conditioning the air and cooling the air down, we are cooling the water down. That's then circulated to the air handlers, and then that is then given to the air into the space, and then the heat from the space that is recovered from the air handler comes back into the water through the heat exchanger in the AHU and comes through the warm water, return water, here at roughly 12 to 13 degrees C. Water chillers need to maintain a delta T of 5 to 6 degrees to ensure that the superheat on the evaporator is going to be perfect and the chiller is within its flow range, right? So when you do a chiller maintenance, you also need to look at the flow rates across the heat exchanger as well, and also obviously the usual servicing that you do for a refrigeration plant to make sure that all cores are clear. But with chillers, you need to be a bit more thorough. And this is what I used to do 15 years ago for all the large commercial companies like Honeywell and the Emirates Stadium, looking after chillers all the way up to 1 megawatt and centrifugal. So this is just like a walk in the park for me. If you remember what I said earlier about circuits and diversity, what I found being 30 years in the mechanical and engineering sector is diversification. If you have a system that can diversify its load in as many increments as it can, that's always going to be much more energy efficient and be easy to maintain, and also be provide a level of comfort that is unrivaled. So the manufacturers have obviously been refining this diversity throughout the last 20 years. So this is what we're back to, having 2 circuits. So they call it a step 1 and a step 2. A step 1 will be possibly a different size compressor and a circuit, which would deal with majority of the load that's coming back. When this gets to 100% diversity, i.e. VAR 1, the compressor runs at full amps and the inverter runs, and then the water temperature is still not hitting the supply temp and the return temp is still kind of high. After a period of time, it will then set up the step 2. Step 2 brings in, and then this will start a low speed on step 2 until it finds a sweet spot and it can regulate and the water temperature coming through the evaporator here according to what's needed in the building. So if the building needs this to be 100% capacity, this will generate 142 kilowatts of cooling capacity. When both steps and both circuits and both compressors and both inverters are 100% ramped with both expansion valve drivers all open, and obviously 142 kilowatts at this age, it needs to be maintained properly. Right guys, so this is the heart of the water chiller. It's a very old water chiller, this one, but it's good to give you guys an example of how water chillers work. And if you have some of this plant and you look after commercial buildings and you're not sure who to come to, then we can definitely help you in that department. Right, so water chiller is essentially a very large refrigeration circuit. This is our condenser coil here with the distributors on each side. So condenser is inside, right? What's here? This very large fan here, belt driven with a duct on it. So what happens is the air is pulled when the fan moves and rotates. It then takes air from the other side of the coil, which is essentially the outside because this is a vented chiller, draws the fresh air across the condenser into this compartment, takes it up out, and then discharges it through the discharge ductwork at another remote location not too far away. The air that's discharged and the air that's taken in are quite a distance away, so there's no cross contamination of the air or short cycling, which will make the chiller overheat. So chillers are essentially a very large extrapolated refrigeration circuit. So the fridge guys will know that's your solenoid valve, liquid line, that's a dryer from the condenser. We've got gauge taps all over the chiller, because when you troubleshoot a chiller, you essentially have to look at things at a local scenario. So you would have to look at whether, if you had a liquid line dryer issue, you check the delta T across the liquid line. If you had slight condensation forming, if the solenoid valve wasn't lifting properly, you'd have some type of disturbance in the liquid line. You've got a sight glass here which all the refrigeration guys know about, which is essentially our viewing glass as far as refrigeration guys are concerned. This normally tells us, it has a litmus paper inside. It tells us the moisture content within the refrigeration circuit. So if you have moisture, it's yellow. And if you're free of moisture, then it's green, which gives you an indicator. This also gives you an idea of how full in volume the liquid line pipe is here. The liquid line gives you an idea under 100% capacity. This should be a glass filled with no bubbles. Bubbles indicate movement and indicate the liquid line not being at 100% volume, which could means in some instances it could be short of refrigerant. But as we full well know, that systems like this that diversify, sometimes you do not get a full liquid head here because you may be only running on one compressor or one expansion valve, low duty with a very slight opening, which would then cause the liquid line not to be at full capacity, right? And these boxes here behind here are the compressors. There's two of these boxes because there's two circuits here, step 1 and step 2. And when it comes to looking at chillers, doing key small measurements that you would do on a smaller air conditioning system, here they are very detrimental. These obviously is a large refrigeration system, so the motors have oil. So what we do on a service is we take the oil out, we then put it into an oil acid test kit, and then it gives us an indication of whether there's contamination or acid present within the oil, right? So as soon as the oil is contaminated like a car engine, then that'll affect the mechanical runnings and the clearances of the compressor. And these chiller compressors are one of the most expensive compressor refrigeration components to buy, and that's why clients always ensure when they have the chiller under maintenance, it's done by specialists. Right guys, when I was talking about the AHUs earlier, this is what these are, air handling units. Very large compartments that are responsible for moving air from the building, conditioning it, filtering it, and sending it through the ductwork in the building to the right spaces, right? So these are large chambers of air. The pipework connecting to the chambers is pipework that provides heating, and if it has a red band on it, it says heating, flow and return into here. They have very large heat exchangers sitting within the chambers, and as the fans move the air across in heating, they'll provide a temperature difference and gain the heat, lose the heat from the water to the air, providing us heating, and the vice versa in cooling. This is what I call as a 3-port valve, right, which sits on the return. Every time you see a valve, it's on the back of a heat exchanger, and then the valve is controlled by the BMS, or if it's a standalone air handler that has temperature sensor settings set onto it for the specific heater set point, it will then control the operation and the flow of hot water or chilled water within that specific battery to provide a perfect environment. This is a very old air handling unit, right? So that's why we've got the pumps sitting outside, and they're belt driven to the central fan pulley. So this is in case one pump fails, there's another pump, backup pump to carry the air handler, ensuring minimal downtime, right? This is really old technology. These days, like you saw in the chiller, it's all in the compartment with the motor and the belt attached to the mechanical fan, but this is all outside. I guess it provides an ease of maintenance and checking as well. So you can check everything while the fans are running, from the motors, current draws, amperage draws, RPMs, and anything like that. Air handling units always have lots of sensors, and these are connected to the BMS system. We've got a frost coil temperature sensor and a pressure switch. These you guys might see a lot. They are pressure differential switches. They're normally across a filter. So this gives you an indication of when there's a great pressure differential across a filter. That means one thing, the filter is blocked. We've got a pressure on this side that has too much of a delta compared to the pressure that's here. And that can mean a restriction, blocked filter. That's the main purpose of pressure differential devices. With there being coils in here, there's another coil in here, and that's for the cooling circuit, right? You can see it's got a fan switch and a drain. And then when you open up the compartments, we don't advise, if you're not trained or skilled and dealing with plant rooms or working in a plant room environment, you do not open the air chamber until the air handler is isolated, right? So in here, this is a very clean compartment. You can see how we've kept it nice and clean. And these are the bag filters. So these are the filters that when the air blows through, they sit in that orientation, and the air comes into this pocket and is filtered. So these are critical to maintain. They pull out like this, and they go back in, and we change them on air handlers annually, depending on the usage. To maintain this large machinery, you need to have a good understanding of mechanical, how the physical aspects of the valves actually work, the control devices of how the valves are controlled, and then the control system that controls them and how it would operate and how that has an effect and bearing on everything else integrated to it, like the cooling and heating coils. So here is the large ductwork here. And if you see these orange dampers, that's a damper motor. These are what we call Belimo damper motors. This controls the vanes and essentially is the air termination point for the outside, and this can shut off the air handler or open the vanes according to the air volume that is required. Guys, so thank you for putting up with the background noise in this plant room, but I thought I'd give you a small insight as to how some of the stuff we look after at iClimate. We do have a background of industrial, large engineering climate control systems that I'll give you a small glimpse today and a few small nuggets of just some of the knowledge behind iClimate. We don't just install AC in houses, we are mechanical engineering across the board.